And please welcome on the stage once again Dimitar Tsvetkov, Samu Konttinen, Roopak, Verma, and Schwegler.
Good morning, and thank you, your panelists, for the great presentations. And I guess we already had more time than we should have, so let's just dive into the questions. First would be a question for Roopak. You just mentioned that next year all the cars are going to have those built-in modems. Don't you think it's going to be a huge disaster from the connectivity infrastructure point of view?
It depends on how that connectivity is being used, in my opinion. Because as I showed, the cars can generate lots and lots of data. But it's not the data that we want. What we want out of the car is the relevant, intelligent information that can be acted upon. So what you will see now is instead of OEMs or other service companies trying to send the data, all the data that's being generated from the car over to some central data center for processing, it's going to start getting very selective, and you will see more and more intelligent processing power that's in the car to make sense of the data and only send the relevant information. So that to me is going to be the key, but you're right, if you start sending all the data, it's going to be a nightmare for the connectivity infrastructure. Hopefully we will do it smartly and send the information that's relevant and that can be used and acted upon. So that's going to be very interesting.
Okay, and let's then generalize the question and ask Dimitar, how do you overcome these bottlenecks in terms of the huge amounts of data that has to be dealt with?
Actually, I wanted to mention during my presentation also that we have a lot of customers in Bulgaria which are using similar technology, and this is, as I said, the new technology is not only faster for the sake of speed, but it's also enabling the new business models. All this is visible now with current customers in Bulgaria. So we are a small market and we don't have to really follow, and I really like the comment Mr. Verma, that we don't have to do the big data project just for the sake of big data project. We really don't have to follow the trends which the world is doing, but this is more like a change in the mindset. We have to change our mindset and think real time. And this is the way we are dealing with all this data coming, because big data challenge is not only amount of data, sometimes the big data challenge is about the reaction, how fast we have to react on the data which are coming. And here the memory technologies like which I presented, HANA, are really key to success.
Okay, then let's go to another bottleneck, which is security.
I actually would like to comment on that one. I mean, IoT requires a parallel network. I mean, the GSM network needs to be replicated with another SLA, with another price structure for IoT. So there are a couple of countries which already do that on a test basis, but that's just super crucial. Otherwise, I mean, the cost structure wouldn't work, and also the SLA of the two networks are not the same, or the requirements for the SLA are not the same. So I think there needs to be infrastructure work that has to be done as well.
But that can take decades.
I don't think so. At least I know in Switzerland we already run a pilot on an IoT network. I assume there are other countries which telcos have this in plan or will have this in plan. It's a requirement in my point of view. Otherwise, that whole thing breaks down. I mean, or you're just not going to send stuff around. Like you're saying, you're aggregating stuff in a car, process stuff in a car. I mean, you have little supercomputers in a car. Why are you sending everything back and then lose the stuff on the way? I mean, there needs to be very smart processing with field gateways and all that kind of stuff.
Okay, then while we are on Internet of Things, how, in your opinion, can you use the big data and machine learning in the Internet of Things?
Car is a great example where I think you do a lot of aggregation in the car, and the only thing you would actually send are model elements that you can use then to predict certain things. I think the there are some issues around security which have to be solved. There was lately an interesting report by a senator in the US, car security of security of connected car. So that's why I think the real sweet spots is in plants, where you actually have field gateways that aggregate the data, and then you actually push the aggregated data to a real-time telematics platform that then actually does predictions. But I don't think you're just going to send every single sensor event that comes along across the wire, because ultimately also you lose connectivity, you only get half of the data, so your data is so noisy you can't use it for building models.
Yeah, that's a good point. Okay, Samu, then question for you. What challenges does big data bring to the security providers?
Well, quite a few things. So I think the first one is that the car industry and many other guys playing with the big data, you need to be really doing a good job. So you design these awesome new technologies, security-wise, kind of a ground up, not something that you kind of put on top of them afterwards. So it's kind of the security by design thinking. That's one thing. And I think the other thing with big data is that that's obviously going to be massively interesting to some other parties as well. And I'm semi-scared. So if you look at how these big organizations who have IT security budgets of tens of millions, and still the bad guys, if they so desire, they'll get through. And this has changed, that this is not just prevention, because we know that it doesn't matter, like you buy all the greatest security products, these bad guys will get through. So it's also about forensics. So how do you understand that somebody has now hacked in, and how do you remediate? So how do you recover, and how do you even understand what has happened? And I guess it's gonna be opening a rather interesting and scary scenarios if the bad guys start to think that what could they be doing hacking into the things like cars.
Roopak, what do you think?
Yeah, I mean, this is a very interesting question. So if you are semi-scared, I'm scared to hack. If a security guy is scared, think about me. No, this is something that we, as you can imagine, worry about a lot. Once you get connectivity to your car, I mean, you had so many examples about how easy it is to hack into things. The last thing you want to think about is somebody hacking in your car and doing what they think might be the interesting stuff, and for you it might be the most scary stuff. I'll tell you, there was an experiment done just a couple of months ago, because the connected cars is not next year or something. There are many cars who have the connectivity today with built-in modems. And there was a ethical group, fortunately, who did a demonstration. They had these 10 of different cars from different manufacturers and showed how quickly they could get into them and take control of some of the functions. Simplest thing, unlock the car because it's got a modem. Simplest thing. But they could do some serious damage, right? Think about it. So your point to building the security ground up is very, very important. Even within the car, when we think about the CAN data architecture in the car, how the data travels from when you apply the brakes to the signal to the processing unit, all that, by the way, is on a network in the car. Car has got one of the most complex network that you can think of. Having that completely separate from your modem is essential. And that's a ground up design. You can't just think of, oh, I'm going to put a firewall in the car or put some security tool in the car and that'll be enough, because somebody is going to hack into it. And when they do, as you said, the simplest thing is they unlock your car, but they could do some serious damage if that was their intent. So really designing this ground up security is my opinion, is the key. And that's what is going to create the trust in people, that they can buy a connected car, they get all the convenience and the e-call stuff that's required. At the same time, they still have control of the car.
And Samu, what do you think about this new network that Bate just mentioned? Do you think it's going to make things more secure or less secure if we have a parallel network for the Internet of Things?
It's a good question. So it depends how you go and build built the network. If you look at the current environment, I think it's maybe a bit more about getting the scale up and rather than just security. So the current GSM network, the GSM security protocols and stuff like that, it's not yet something that hasn't been hacked, and we know that what is the great length that somebody can go into, like NSA hacking into the SIM card manufacturers and getting the kind of a backdoors all the way to the SIM cards. And that's what the persistence threats is all about. You go after the weak spot for not for an hour or week or day or something like, but years, and eventually you get in. But I think it's a security question. But I think it's how I see it. It's more about sorting out the scale than just the security.
But if we just start building a new protocol from the scratch, do you think we can make it better and more secure than GSM is?
Yeah, definitely. I think the technologies are pretty advanced already. So I think the industry could do a better job. But GSM has been quite good. I'm only semi-worried about that too.
Okay, let's get then from the cars to a more enterprise segment. And Dimitar, you were talking about these solutions that SAP provides, and the question is it only for bigger enterprises? Is it only for bigger companies? Is there anything smaller ones can do with big data?
Actually, yes, and the Bulgarian market is a very good example of this. We have quite a lot of customers using similar technology in a country which is 7 million people. I will not say we are a big market. So everybody can afford nowadays, because of the new consumption models like cloud or software as a service. Every company can afford to have. Most of the companies can afford to have similar solutions. And as I said, it's not really a manner of size. It's more a manner of how we think about the technology, how we think to use it. And I'll give an example very close to this one, which is the network economy. Network economy in terms not connected via IP protocols, by business processes. And there are some such networks like, for example, Riba, which has 1.5 million of customers. Imagine what is going to be for a small company in Bulgaria to enter this market. It's a new virtual market when each company can enter and sell or buy services, sell or buy products. For example, Bulgarian company can sell food for NASA because they will see all the tenders in NASA, for example, and so on. All the new technologies are now helping even smaller markets. Moreover, all the big companies also are taking into consideration also smaller markets. So more and more companies are focusing on smaller markets. So most of the companies do have special offerings for smaller markets. So I do think markets like Bulgaria can benefit from the solutions which the big countries can use. And we see this every day.
Do you have any good examples of small businesses who need big data projects?
By the way, this is I will go back to the security. Security is a very interesting topic because it generates a lot of data. So security is a kind of a big data. Probably you'll agree with me. It's so having an enterprise security system which should in real time analyze or a fraud management system. This is most of the companies, mid-sized companies will need such things. So this is also. And one comment on the GSM network, because I was working for several telecoms in my past. More or less the GSM network, at least in countries here, it's older generation, but with the new generations which are coming, I think this is more and more going to increase the bandwidth, and I don't think that it's going to be a separate network for Internet of Things. I rather think we are going to increase the capacity of the existing GSM network somehow, and it's visible, rather than having and supporting totally separate equipment for Internet of Things only. I mean, it's just my personal opinion. To add to the other speakers. I don't know if you agree with me somehow.
Yeah, I agree. So as an example, our security cloud, where we take the decisions like the machine learning, like Roopak, and introduce those. So we handle about 5 billion kind of a cloud lookups a day, so about 60,000 per second. So that's the amount of kind of transactions we take to our cloud just to justify whether this website is bad or not bad, or whether this piece of code is malicious or not malicious. So 60,000 a second.
So this also means that big data is only getting bigger, right? That there's not going to be less data, there's only going to be more. So a question for Bate probably. Do you think there's going to be any kind of a breakthrough in the way we deal with big data, or do you think it's going to just develop the way it does now?
From my personal experience, the challenge is that it's very hard to get insight from a lot of data. Because every big data project, it just takes ages to transform, to kind of find patterns and so forth. So for me, big data doesn't necessarily mean you have this huge pool of data. It just means you have access to it. But it doesn't mean you have to process all of it. I mean, for machine learning, you can't throw a terabyte of data at an algorithm because you're going to wait a long, long time. Many machine learning algorithms are in memory. So what you have to be able to is extract samples that you actually can work with. So personally, you saw in my presentation, I was saying the most important thing in every big data project is what's the problem you want to solve? What's the question you have? And then look at the data that can help you doing this. I think it's a wrong approach just starting with the data and then think about what's the answer I'm going to get out of it. Because I can tell you, most likely nothing. You basically waste compute cycles. Or you're a scientist and you want to find certain patterns. But for me, the key thing is have a question. When it comes back to you, question needs to be answered soon. You come back with a thesis. You basically work with the business, and then you refine, get additional data sources attached to it. So it's not the size that really matters. It's more the big data tooling that makes it big data.
I absolutely agree. I mean, you always got to start with what problem are you trying to solve? What are you trying to do for your business? Another thing I will add, I mean, being from a non-IT company on the stage is I think the partnerships on how you leverage expertise is going to be the key. I mean, look at Ford Motor Company. We got a big IT organization. I mean, 10 years ago, we thought we could do everything ourselves. I mean, we got anywhere from 10 to 11,000 IT professionals being a car company. But I can tell you right now, there's so much stuff that we have to leverage our partnership with our IT partners. Otherwise, we won't be able to do it. So I think the collaboration and the partnership and the service delivery model is going to be the key. I mean, I'll give you one example. We are putting the speech recognition software in every car. It may sound simple. You write algorithm and make it learn. Then you realize there are 150 dialects just within Europe that you have to worry about. So your speech recognition algorithm has to be extremely sophisticated and really learn from this huge data sample. So you have to rely on people who have that expertise and really play in that space. We can't do it, so we have to build that partnership. I think this network or partnership is going to be so key to really leverage everything that's coming at us.
So what exactly, which kinds of expertise are going to be in most demand in this aspect?
Oh, I mean, it's different for every field. I'll give you a couple of examples. I mean, we went to China and we're going to have a connectivity of the car in China. And we had a way to get their data in through the network into the data center for some smart analytics. The environment in Asia Pacific from a connectivity perspective is very unpredictable. That's probably the best way for me to say that. You go to different countries from Vietnam, Indonesia, India to China, it's different. So how do we do it? We are relying on the partners and the cloud technology to give us that connectivity. In fact, we are using Azure in China from Microsoft to get that connectivity in China, for example. But that's the kind of stuff that you have to do. Again, relying on different universities and the companies for the speech recognition expertise, it's going to be the key. And I can give you many, many examples of finding it.
Thank you so much. We're out of time for now, so let's give a hand to our great panelists. Thank you so much for presentations and answers.
Thank you, guys.